Hey guys, here we are going to talk a little bit more about solutions and how we measure their concentrations. To review, we went over this at the beginning of the year. A solution is a homogeneous mixture. Now remember, a mixture is when there are more than one type of particle in there. So if you had two different types of molecules or an element in a compound, those are examples of mixtures. We talked about that at the beginning of the year. And a homogeneous mixture, the particles have to be evenly mixed throughout that mixture. And it's made of a solvent. Essentially, a solvent is what there's more of in the mixture. Normally, you're talking about the liquid. If you're talking about making a solution of a solid and a liquid, it's normally the liquid. Water is the most oftentimes considered the universal solvent because it's used to dissolve so many different types of things, and it has very unique properties. The other part of a solution is the solute, and that is what's being dissolved. It's normally, in this case, in our class, it's going to be the solid. But you can also have the solute be a liquid as well. As, for example, if you had a solution of water and ethanol, and you put you made a solution adding a small amount of ethanol to a volume of water. Now that would, the solute there would be ethanol. So keep that in mind. So concentration is the ratio of amount of solute to how much solution is being made. And you guys are very familiar with this if you've ever made lemonade or orange juice from a frozen concentrate. If you've ever tasted that concentrate, it is very sour and it tastes terrible. But what we do is we reduce that concentration by increasing the volume by adding water. And that makes a delicious orange juice or lemonade. So, let me do some molecular modeling for us. Let's say that one dot here represents 1 mole of NaCl. And here, in example A, I am going to dissolve 10 moles of NaCl. Let's just represent. Remember, a mole is just a number of particles, how chemists measure particles. And to B over here, I dissolve 1 mole of NaCl. The one that would have a higher concentration is A. So we say A is more concentrated than B. And we see that we have 10 moles in A, 10 moles per 10 liters. So that is a ratio of 1 mole per liter. And we're going to learn a special notation to determine that in just a little bit. To B, we have 1 mole in 10.0 liters, or 10 liters. And that would be a concentration of 0.1 mole for every liter. Now, there's a special term for this concentration up here for A and B. Let me circle that. And how we calculated that. So 1 mole per liter, that would be a 1 molarity solution. So molarity is just how a chemist measures concentration of a solution. It's just the ratio of moles of solute to volume of solution. So we take the moles of solute divided by the liters of solution. And that's the molarity. And how we write this, if we look back up here to example A, 1 mole per liter, you'd write that as 1 M. That big capital M represents moles per liter. So that is exactly what that means. 1.0 M, 1 mole per liter. The same thing over here, this would be a 0.1 molar solution because there's 0.1 moles per liter. And we can use this to calculate the different quantities, similar to how we use molar mass to calculate moles or mass. So, an example here, this notation down here, if we look at example of 0.50 molar HCl, that's how you would say that. That the capital M indicates molarity. That's why we can't abbreviate moles with an M. So we have this means right here 0.50 moles of HCl per every 1 liter of solution. You could also say, depending on what units you're using, since 1 liter is 1,000 milliliters, you can say 0.50 moles per 1,000 milliliters. But normally we're just going to stick with liters for our class. So another example, 2.0 molar NaOH. That means there's 2.0 moles of NaOH for every 1 liter of NaOH solution. So if I had 2 liters of, let's say for example A, if I have 2 liters of HCl, of 0.5 molar HCl, I can figure out that I have 0.50 moles of HCl for 1 liter of HCl. So that would mean I have 1 mole of HCl dissolved in that 2 liters of HCl. And let's say I needed 1 mole, let's do a different number, 0.5 moles of NaOH. And in this second example here, now I know that for every 1 liter there's 2 moles, so I would need 0.25 liters of that NaOH solution. That would contain 0.5 moles of NaOH. So we're going to be using this for the rest of the year. So get used to it and practice it, and make sure you use proper notation. Like don't write M for moles because that looks like you're writing the molarity. So keep up with it and practice it to get perfect at it.